Diego Google. Welcome to tonight's San Diego Google Developer Group. Today is August 10th, 2021. And our topic, as you can see on the screen, is Android CICD at scale using Kubernetes engine. And we have a guest presenter, Mr. Donovan Carter. I will hand over the screen to you, Donovan, if you'd like to introduce yourself and tell us a little bit about yourself and a little bit about what we're going to be talking about tonight.
Yeah, thanks, Kyle, and good to see everybody. Thanks for having me out. This is a fun thing to do. Love talking about Kubernetes engine, as Kyle will tell you. I won't shut up about it most of the time. Once you put a coin in my slot, I don't stop. And a recent fascination of mine has been getting to work with our Android team, specifically within the mobile DevOps space. And I'm really excited to talk about this. Probably a year ago, if you had told me I would be talking about Android CICD, I would have told you that I don't know anything about Android or Java, and Gradle commands make me nervous. So there's no way that's happening. And then here we are. I mean, who thought we would all be here where we are in a lot of ways a year ago? But we'll get into that. Let me make sure that my presenter mode is working. Cool. So a little bit about me. My name is Donovan Carter. I'm a senior DevOps engineer, guitar player, beer drinker. I have a 2-year-old son, 2.5-year-old son who keeps me going on the weekends as if I needed rest. I love Kubernetes, CICD, and I'm very passionate about the developer experience. That's why I got into DevOps. I come from a sysadmin background, got into programming and development, and then realized there's a world of opportunity with that background to enable people. I'm also an Enneagram 2, if any of you are into the Enneagram, so I love to help people. I carry other people's burdens unasked and willingly, oftentimes, which I think is a specific torment/skill set of mine that makes me probably good at DevOps. I care a lot about developers being able to enjoy what they do and deliver at a high velocity. My preferred programming language is Go. I'm a big gopher and argue with the JavaScript and Java friends that I have at work quite frequently, especially being in this particular realm. Big sports fan, as you can tell from some of the flags adorning my background. And I grilled up some fantastic thick-cut pork chops tonight on my Kamado Joe. I love barbecuing and get to do it as often as I can. I'm braving 90-degree weather today out over my 350, 400-degree grill for flavor. So that's me in a nutshell. There's more, but we're gonna keep rolling. Tonight, I want to talk about using Google Kubernetes Engine specifically to solve the problem of Android CI/CD. I'm not going to talk so much. Yeah, absolutely. We'll be happy to come and talk about barbecue. Again, that's another thing. You put a coin in the slot, the record just keeps going. But Android CI/CD, I'm not going to talk so much about the orchestration layer. I use GitHub Actions. Google cloudbuild is a great option, especially with private pools. You could do something very similar. If you're using GitLab, one of my favorite barbecue videos and barbecue teachers on YouTube talks about it doesn't matter what the smoker is that you're using, the equipment that you're using. We're going to talk about the skills you need to get that barbecue no matter what you're using. And tonight we're going to talk about what you need to do to get the experience that I've found to be really great and our developers really like using Google Kubernetes Engine, what your preferred orchestration tool is, whether it's Jenkins or anything else. Totally your flavor, up to you. So this is a little agenda about what we're going to talk about, but I do have a disclaimer. The disclaimer is this works for us and our team. We love it. We're happy with it. It may not work for you and your team. That's totally okay. One of the awesome things about cloud and cloud communities like this is that people are sharing how they do stuff. And they're talking about it and they're saying, oh, hey, I did this with this and it works great. Oh, man, that's awesome. I'm going to go copy that. 20 comments down in the GitHub issue that you're reading, somebody else is like, whoa, I solved this a different way. I, as a musician, feel like there's a lot of creativity that goes into software development and in solutioning in general when it comes to tech. And that's one of the things I love about it. So please feel free to take what you want from this presentation, use it, try it out with your team, or say, actually, we really like what we're doing and it works for us. That's totally fine. This is a way to do it. Not saying it's the way or the Google way to do it. It's a way. So what's the name of the game? Developer confidence in the CI/CD pipeline is the name of the game. We believe that where I work at Dexcom, I'll drop it. We believe that the pipeline, what goes into the pipeline, the developers own. The DevOps portion of that is providing the infrastructure underlaying the pipeline. And we want our developers to have 100% confidence that if there's a build failure or a build issue, the pipeline is not likely it. The infrastructure underlying the pipeline should be like one of the last things that we check or second guess, because we always want to have confidence in that pipeline. When it gives us a failed test or a failed build, we should be looking at the code and trying to get to the best code that we can when we're delivering and deploying. So we had some questions to ask. We started out with a GCE managed instance group using custom images and startup scripts, which is a great way to start out. I've done this for other teams on the server side where we're building Docker containers primarily, and they're great. They have a lot of benefits. Auto scaling. You can auto scale over a ton of different metrics, including, I believe, custom metrics, which is great. You have more fine-grained controls now than you did several years ago over that auto scaling as well. You've got a lot of self-healing options. Expose a health check endpoint, and the managed instance group will replace bad instances for you, so you don't have to worry about stale instances. If you're into Packer or Ansible or things of that nature, you can have configuration as code and codify your managed instance group. You can use Terraform and things like that. You also have costs. Since you're scaling up to accommodate your needs, that's awesome. When you need to expand, you scale up. And when nobody's working at night, you can scale down. All these things are great. Things that we've found with switching to GKE for our Android builds is that we found some other things. Costs is a big one. For the cost savings that you get with auto scaling, scaling up, scaling down for managed instance groups, that's cool. But with GKE, we were using N2 standard 8s for our builds in GCE. We've now switched to E2 standard 8s for our nodes, but we're able to accommodate about 2 build containers per node, completely segmented and separated from each other. So we have a little bit of that auto scaling economy, whatever you want to call it. We're packing more stuff into a similar sized instance to what we were using before. It's actually a slightly cheaper instance before. And it scales up and scales down at will. You don't ever have to think about that. The other big thing, and you guys will probably appreciate this maybe even more than I do, I think I appreciate it a whole lot, is we get a clean build environment every build. One of the things that drives me and our DevOps team nuts is having a build failure, going in, investigating the node or the container in the build environment, and seeing, oh, the previous build flipped this switch in Gradle or activated a GCP service account, and now all of the builds subsequent on that node or build container are completely not going to work. They're going to bust. And it's not because of anything wrong with the code. It's because somebody came in and mucked about with the build environment, and now things are all messed up. With GKE, we've been able to accomplish one container spun up for one build and then thrown away. And I'll talk a little bit about that in a minute. But it's completely changed how much time we as DevOps engineers are spending looking around at build failures. It used to be 2 to 4 times a day. Now we maybe get a build failure that we need to investigate once a week just because of this change. The other stuff is great, but having that clean build environment for your build and making sure you're not caching any Gradle artifacts. Granted, sometimes you do want to do that, to each their own. But for us, the opportunity to have a clean, brand new container for a build and make sure that that environment was spotless made up for any of the gains we would have gotten, or maybe a little bit of the time taken to bring those artifacts in and download them. Some of the other benefits that we've seen is time to auto scale. We haven't seen a real big hit in our build times overall. We managed to kind of dial in the resources, and we're actually still dialing in the resources. I was looking earlier today preparing for this conversation, and I was like, oh, we actually still are slightly over provisioned. We could actually reduce a little bit and even get more auto scaling economy out of our build agents. And the last one is operations. I mean, we are a Kubernetes shop on our platform side for a platform DevOps team. on the backend servers are all mostly Kubernetes engine. We have a lot of Kubernetes knowledge. There's cool things. There's continuously cool things that we can do with Google Kubernetes engine that the community is doing. It just makes sense to add this to what we already do, as opposed to, I hate to say, a pet managed instance group, because that's not entirely true or fair to managed instance groups. They still have their place, but we're able to apply our operational knowledge and build pipelines that are repeatable for both our build agents as well as our software. We're kind of using similar pipelines for our build agents, which is kind of cool. And the configuration as code is very plain and diffable. Again, if you were using Packer or other management tools, I believe you could achieve similar things, but I'm used to looking at Docker files. That's what I've done most of my career. I enjoy it. I'm used to looking at YAML. I know what I'm looking at. Some of the folks on this call may not necessarily be as interested in that, but our team is able to go and look at those things and say, yep, we need to update a version of the dependency. Boom, it gets deployed the next day. Everybody wins. It's really quite fun. So that said, there's some interesting challenges. I mean, I'll go out on a limb and say we're using Google Kubernetes engine and maybe Kubernetes entirely. It's not just GKE, in a little bit of a weird way compared to, I think, how it was probably designed for. Kubernetes at its core is really running stateless workloads. It's web servers and scaling up and scaling down when traffic comes in. And so there's been kind of some interesting problems that we've had with the autoscaling, horizontal pod autoscalers that we're using, as well as just kind of using a tool and maybe not the way it was designed for. I was very averse to pod restarts. Pods probably shouldn't restart. Obviously, that's part of self-healing, but if you see a container with 5 to 10 restarts, oh, why is it restarting all the time? That's not good. There's got to be something wrong. When you're using it in a CI system and you want a repeatable build or a clean build environment, and you actually want Kubernetes, we're using that automatic restart so that when the container exits with a 1 or a 0 exit code, really anything, it restarts it to make it available for another run. But I want to start talking about autoscaling. GKE autoscaling is too good. Horizontal pod autoscalers are incredible. They basically allow you to set a metric that GKE, Kubernetes engine, looks at. And similar to a managed instance group, when a metric threshold is met, say 30% memory utilization across your deployment, it'll start bringing up more replicas to balance that load. So we found for our CI process that memory is really the constraint that you want to look at. CPU can kind of spike depending on what Gradle's doing, but there's a lot of stuff happening in memory, specifically as it relates to Gradle. And again, not an expert on Gradle, so please don't quiz me about that in the Q&A. Although I would like to take the moment to invite you to drop questions that you might have in the chat. When I go through a slide deck, I like to try and get through it and then get to questions after. So I will be happy to answer any and all questions, as long as they're not deep dives into how Gradle works at the end. But Gradle does a lot of stuff with memory, especially when you're running in a containerized Kubernetes environment. Anything that would get persisted to disk actually gets persisted in memory. So we know a build is running on a pod when the memory starts to shoot up above 30%. If all of our pods are above 30%, we know we need another build agent, because we always want to have a build agent available for a job. So if there's a job, it shouldn't sit in the queue for longer than a few seconds, as long as it takes for the API server to allocate it to a build agent, ideally, which we've been able to achieve. However, as you may know with autoscaling, there's scale up and there's scale down. Well, scaling up is great. We want that. The scaling down is when we get screens like this, when it's our fault as a DevOps team. Hey, my build was running and then something happened and I can't see that build agent anymore. What happened? Oh, well, it was a quiet time. We didn't need all of the build agents, so we started scaling some down. The API server started scaling some down. Oops, sorry, just rerun your build. Our orchestration tool is GitHub Actions. Other tools may have mechanisms for like retrying a failed build. Unfortunately, GitHub Actions does not. We're looking at other ways that we could accomplish auto-scaling. But for right now, we've kind of gone with this approach. And I apologize if the sight of YAML makes you a little squeamish, but I love it. This is really fun. The horizontal pod autoscaler and the V2 beta 2 API has an ability to change the behavior of the scale down or scale up. You can actually set policies for scaling down or scaling up, and you can also order them in the preference that you'd like them to apply. This one's a pretty simple one. It just says, hey, if you think you're going to scale down, don't. We don't want you to do that. If we scale up because we need to expand, we're going to throw the cash at it. We're not really spending that much money on it when we scale up. So if we scale up to be able to handle everyone running a build at the same time, great. We want that. We never want a developer to come to us and say, hey, a build agent, scaled down and realize that it was our auto scaling that caused the problem. That's, I think, the appropriate attitude a DevOps team should take towards the build pipeline during the business day. Now, we're able to do this because at night we redeploy all of our agents from scratch. So whatever is in our main branch gets redeployed each night to our production build cluster. And that resets the auto scaling back to our minimum replicas of 3, which is great. So we have no containers, no pods hanging out from the previous day. They all get wiped. And when we start running builds, which is usually nowadays it's 8 a.m. Pacific time, we start to see that start to climb up and spin up, which this has been awesome. I mentioned earlier, and I was a little bit excited to talk about it, and for good reason. This is our startup script for our GitHub Action containers, and I've chopped it up just a little bit because this is pretty easy to find, except for line 8. Line 8 is an undocumented flag in the GitHub Actions API that basically says, hey, register this runner to run a job, but only keep it around once. So basically, once the job's completed, go ahead and exit the runner and tell the API server that it may come back. It may come back using the same name, or it may not, but just run the job once. This is how we've managed to achieve. So Docker containers, one of the cool things about Kubernetes, just to kind of segue and aside and maybe set this up a little bit better. One of the awesome things about Kubernetes is that it solved the problem of, hey, I'm running Docker containers and I've got my Docker Compose or my Docker containers through my Docker run command. But then I just realized that one of them died and it's been down. Kubernetes solves that because anytime a container dies, it says, I know you need at least 3 of these because that's what you told me in the manifest. I'm going to make sure to restart this container and keep it running. Unless it starts to thrash the system, then I'm going to politely put it to the side and say it's in crash loop, back off. I don't want to take up resources that could harm the system. It's part of Kubernetes self-healing. In this case, we're not really using it to self-heal. We're actually using it to cheat a little bit and say, hey, run this container and run the job. Once the job's done, it's going to exit, and then Kubernetes is going to restart it. Again, a little undocumented flag on the run.sh for the GitHub Actions runner startup script that's not a documented API as far as I can tell, has given us so much more confidence in our build environments and make sure that that container and all of that Gradle caching that would get stored in memory as a faux persistent disk is awesome. We also would run into memory limit problems. Gradle's pulling down different artifacts to build different apps and different libraries, persisting those for the build, and then we're getting killed, and our agents are crashing and causing developers to second guess the pipeline, which is what we do not want. This has solved that problem as well as the noisy neighbor problem, and it works 60% of the time, every time. It actually works way better than that, but I couldn't help but use the reference. So with that said, I have flown through my slides, and I'm actually okay with that. I will pause for questions. I think before I do that, just to kind of sum it up, GitHub Actions has things that we use to achieve this, but I do want to stress that whatever you're using, this is possible. And also we'll give your DevOps team, your mobile DevOps team, if you have a DevOps team that's specific to Kubernetes or to mobile, an opportunity to play with Kubernetes, which is a really fun and hot technology. GKE is a great way to leverage it. I've used other cloud providers, Kubernetes as a service. GKE is by far one of the best. And it's radically changed our build experience and our DevOps experience working with this technology. But it doesn't have to be GitHub Actions, whatever you want to use to orchestrate, it's there. One of the things that I'm actually working on in my spare time is using Canico or Docker and Docker. They're two different technologies to build Docker containers within Kubernetes. I'm close. I haven't gotten it there just yet, but it's definitely possible to run all of your CI/CD within containers in Kubernetes and ditch Jenkins running on a GCE VM or VMs in general, which I'm really excited about. So thanks for listening. If you have questions, I'm here, and hopefully we have someone that can answer them.
Awesome. Thank you, Donovan. And please don't be shy. I was just capturing some resources, some links in there. Don't let that distract you too much, but I want to get them into there. Richard, do you want to come off mute, or want me to read your question?
I can ask. It's great to see that you're using Kubernetes for the workload. What build system orchestrator do you use to fund that?
Yeah, great question. We use GitHub Actions. GitHub Actions is a CI/CD component that's a part of GitHub. I was actually going to try and pull together a demo on my personal GitHub to show like how easy it is to set up GitHub Actions. They actually give you templatized YAML basically to start up a pipeline from right within the GitHub screen. So if you're looking at a repo, you can click on the Actions tab within that repo, and it'll give you a bunch of different examples. Node.js, if you're using Android, it's got an Android one, Terraform, things like that. And we'll let you commit right there a pipeline. And then you can run it on GitHub's workers. They have workers as a service to run your pipeline, like Ubuntu, Windows. I don't think they have Mac OS at the moment because that's the one that everyone wants. But you can run it in their cloud, or you can run it on self-hosted runners. I probably didn't do a good enough job of setting the context, but if you guys have ever installed Android Studio and some of these NDKs and things like that, they're enormous. You don't want to install those every time you run a build. You'd like those to be there already. And so what we've done is partner with our development teams to say, hey, give us the version of Java, your dependencies that you know are going to be there. Probably not the ones that change frequently, but the ones that are really painful and contribute to long build times because you got to download them. Give them to us. We'll put them in part of a Docker container, and then we'll use our self-hosted runners using GitHub Actions to run your builds. So we've got some static code analysis tools that we use. We've got some security scanning tools that we use, things like that, that cybersecurity is coming in and saying, hey, can you put this in the runner so that people can use it? And then we provide those things as a service. GitHub Actions does a great job of orchestrating that for us, and our developers really like it because it's all within GitHub, and that's what we use for our source repositories. And so it's been a big hit. But like I said, you could totally use Jenkins and follow a similar approach, Dockerizing your containers and then just making it available for work, and then telling whatever your orchestrator is. I think cloudbuild has private pools, which could also work in a very similar way. I haven't checked it out yet, but I'm pretty confident that it could work the exact same way if you wanted to be self-contained within GCP.
So one follow-up question on that. For your build container, which actually you use for building your Android application, I'm looking for similar solution at this point, which is, if I understand what you say correctly, is that you craft your build container for Android and basically just install, but basically you build that container with all the requirements, Android Studio, all the at least a majority of the libraries that is pre-downloaded, and then just create that image so that you can save the download time, and then so you just spend most of the time just compiling the Android application.
Yep, absolutely. No,
okay.
You hit the nail on the head. We use an Ubuntu base image because that's what we were using before. And in my experience, Dockerizing things just easier when you keep that base image as like for like. You can always trim it down later. But we start with an Ubuntu base image. We install Java. We install just kind of the various command line tools. We install the Firebase CLI because we're running, we're putting builds in Firebase. We're putting builds in Artifactory. We have an internal store where people can go, internal parties can go and download applications. So like if execs want to try out the newest version of our latest app, they can go to the e-store and download it and sideload it onto their Android device, or someone can do that for them, and away they fly. So we're actually deploying those to 3 different places. And another thing that I didn't talk about, because I should have, is that we use CloudNet to secure our communication. So that for like some of these internal things, we want to make sure it's IP whitelisted and bound to a trusted IP. GKE helps us do that. You could use CloudNet with the GCE instance group, but it's been real straightforward with GKE for me, which gives you another thing. If you need to upload to a trusted place where cybersecurity is going to say, hey, it's got to come from a trusted IP, CloudNet's a great way to do that with GKE. But yes, there's a couple of examples on Medium. I'll try and go find them that help me kind of get this process started. But a lot of it was working with developers and kind of figuring out what their needs were to try and put that into the container just to reduce the build times as much as we can.
Cool.
So you mentioned
how big's the container?
Oh, I'm not proud of that.
Yeah, I figure it's gonna be big. I just wondering how big that is.
Yes. It's been a minute since I looked, but it is anywhere from 3 to 5 GB. So it is a lot bigger than my beloved distroless Go containers, which are like 120 to 130 megabytes. They're big. They still pull relatively reasonably as far as scaling up goes. There's more latency than I would like, but again, we've made the decision to, okay, if we trade time for anything, we're going to trade it for consistency. And consistency is one of the great benefits of containers. We love startup scripts, but we ran into so many issues with, hey, we got the wrong version of Git installed, and so we can't go use the Git client to do this special weird thing that we were doing with Git. I think it was submodules, which are still a pain, but we would run into issues like that, and it just caused so many problems for us. And having everything in a container that's pre-built and ready to go has really helped a lot, even if the pull times are in the minutes.
Hey, Donovan, you mentioned Artifactory, which you, from what it sounds, used to distribute ready packages to test out different versions of your software. But Artifactory is a general repository for all artifacts. There are others like Nexus too. So why did you decide not to maintain your own cache in the form of this repository? Is it too much overhead so that you can have every version of every library which you need across all of your Android products cached locally so that you don't need to download them?
No, that's a great question. So we do use for Maven, like caching Maven artifacts, and forgive me, this is where I get a little bit out of my depth, but we do cache our Maven artifacts within Artifactory. And I agree that Artifactory may not necessarily be the right place for app distribution. If you were counting, as I mentioned it, we're distributing via Firebase. We're distributing via our own PHP-based store. And we also distribute to testers through Artifactory. Now, one of the problems that we have is that we have maybe some redundant tooling there or some redundant systems. Artifactory has saved us a lot with some of the recent outages for things like public mirrors for some of these dependencies. So Artifactory is great for that. Is it the right thing for app distribution? I couldn't tell you. You may be right about that. I personally think Firebase is really nice and has a really friendly UI. And it's a hosted service, whereas we do have to maintain Artifactory. But we do leverage some of the caching, and it is mostly due to how internal teams have worked historically and kind of migrating towards a single place.
Thanks, Donovan. Thanks, Fetlin, for the question, and Richard as well. We have another one in the chat. Chris, did you want to read that out, or do you want to grab that, Donovan? Any comment on that?
Yeah. I was just curious. You had mentioned Docker and some other problems you're trying to solve. I was wondering if you had looked into scaffold at all as like a way to kind of abstract how you're doing your build, test, and deploy, like across the board.
Yeah, no, it's a great question. I love Scaffold. It's been a project that I've followed since I saw folks talking about it at Cloud Next a few years ago, and one that I've used a few times. I chose not to use Scaffold for this specifically because the team's not well versed in the tooling, and so it made sense to kind of use a traditional pattern of having a workflow that did that within GitHub Actions and making that part of the pipeline. Scaffold's gotten really good, and there's actually scaffold builders for cloudbuild, which I've used. And I think some of those are starting to become GA, which is awesome because then there's just one action and it does the whole thing, and it kind of gives you another YAML to put that in there. We are using Customize for rendering our manifests, which is another thing that can play with Scaffold. But for our GitHub, building our GitHub runners, just kind of decided to go with a more traditional, like, I guess I want to say easier to follow. Like Scaffold makes a lot of sense to me, but I'm also been following the project and I keep in touch with each update. It also changes fairly rapidly and fairly quickly. Whereas Customize, I think, has been a little bit, they do different things, admittedly. But I've tried to go with tooling that has a little bit more longevity, and maybe has smaller incremental updates opposed to like some of the bigger changes. One of the challenges I think with Scaffold is that you have to update the API version fairly frequently because it is changing so much. Still think it's a great tool, and if I run anything that I work on just kind of by myself, I almost always use Scaffold because that loop, Scaffold dev, is so great. Builds a container, deploys it to Kubernetes, and then tails your logs. What are you going to do if you're trying to deploy something? You're going to build it, you're going to push it, you're going to deploy it, and then you're immediately going to go looking for those logs to see why it did or did not work. Scaffold does that in one command, and I think it's great.
Yeah, just full disclosure, I'm working from the Google end. I'm working on a Golden Path initiative that is basically taking Scaffold as the blueprint, and using that across Cloud Code, Cloud Build, and Cloud Deploy, which is going to be public preview pretty soon here. So yeah, just curious. I wanted to get your feedback. The stuff about the API, that's great. I've definitely heard that that's a pain for some, but that's really good feedback. Glad that you glad I asked.
Yeah, I also really like that it has plug and play with Cloud Build, and you can kind of specify that. With using GitHub Actions, we already have kind of a place where our YAML goes for our pipeline. And so I'd worry about it being confusing for my team specifically to know like, oh yeah, well, we edit this one, but then we also need to go and do that. Full disclosure though, because our images are so big, I'm actually telling GitHub Actions to call Cloud Build so that I can get an E2 standard 32 instance, because I need I do actually need that memory to build these containers when it's downloading and caching all those dependencies. And then for time, I'm using Canico as the cloud builder because it has such great caching, which is why I'm trying to figure out how I can just put all of that into a cluster. And maybe private pools is the way to do that. Trying to build it on a just standard Ubuntu latest image instance in GitHub Actions, we would run out of memory real quick.
Wow. Yeah, I didn't even think about that. That's crazy. Cool.
Fun problems that you create for yourself to solve.
Everyone else is mulling over the discussion. Anybody have any other questions you'd like to throw out there for Donovan?
Yeah, I appreciate all the questions so far. Great topics, great questions. Clearly don't have any problem chatting about this stuff. And it's been great so far. So I appreciate the feedback and the time.
Oh, thank you, Donovan. Thanks to the audience as well for the participation and the interest here. I've been tossing a number of links in there that hopefully are not too distracting for you as you get sidelined looking at some of this information, but you can capture them and then we'll include them in the follow-up the recording when we post it.
Yeah, no, I was happy to see the customer success story from JFrog thrown in there. I was really happy to see that one happen. One of my good friends and colleagues worked on that. So I was very stoked about that. A very cool opportunity to work with cool new things and achieve a really cool end result for the business, the developers. That's one of the fun things about partnering with Google, and some of the stuff that we get to work on is cool stuff like that.
Thanks, Donovan. We think it's pretty cool working with you too.
Oh, shucks.
Awesome. Well, if we don't have any further questions for Donovan, we can let him catch his breath here. Don't disappear on us or anything. Presenters are definitely welcome to participate in the drawing for the giveaway. While I pull that up, let me share slides here, and I will do one more plug for next week's presentation. So today has been Android CICD at Scale by Mr. Donovan Carter. Thank you, and there you are. Next week we have another presenter, and this will be on Wednesday evening, Travis Dupuy. It's going to be talking about data stream, which we'll talk about some continuous change data capture on GCP. But what I'm sure everyone has been waiting for is this virtual giveaway. Thank you for sticking through to the end of the session. So everyone who is here is definitely eligible, and that includes you as well, Donovan. So I have actually like physical items as though we were doing a face-to-face type event that if you are interested in them and you want to submit, we'll do the raffle. So stickers and pens, and then I actually have a new one in a bag, Google Cloud backpack that's sort of got some type of a handle on there as well. Maybe it's useful for running to the beach if you're here in San Diego in particular. So if you can type just your first name, right, Svetlin, into the chat.
Just your first name in the chat. Whoever wants to take part, participate in the raffle, please. And at this point, we can stop the recording, Kyle, I guess.
Yes, we will. So we'll stop recording there. It will be a mystery who won the prizes. Thank you for joining this session on San Diego Google Developer Group. We'll see you next time.